Aristotle is attributed with once saying, "All men, by nature, desire to know." For those of us college students, this statement should really hit close to home. After all, we spend nearly every waking moment of every day, and some of our sleeping ones too, trying to learn something that we didn't know before. Indeed, it could be said that this quest for knowledge is the universal goal of the human race. For essentially all of recorded history, people have been trying to better understand the world around them. And as our scientific knowledge has increased, this has led to ever deeper delvings and more complicated and comprehensive theories about the universe. For thousands of years, people have looked around them and asked, what is all this made of? How does it all work? The ancient Greeks were among the first to try to explain the natural world in simpler terms. In their philosophy, they believed that everything was made up of four different basic elements: air, earth, fire, and water. As scientific knowledge progressed, atomic theory was formulated. This says that everything is made up of different types of atoms, also called elements. These atoms link together to form molecules, which then combine to form ever more and more complex substances. The atomic theory hugely helped with understanding the natural world, but it still left a lot of unanswered questions. More recently, atomic theory has been greatly expanded on to help answer some of these questions. Brilliant scientists like Schrödinger, Hertz, and Einstein made incredible discoveries that hugely increased our knowledge. It was found that there are even smaller particles, such as photons, electrons, neutrons, protons, and that those particles make up everything that we see. The problem is that there are still a lot of unanswered questions, such as where do all these different particles come from? Why are there so many different types of fundamental particles? How do they all work together, and what makes them work together? No scientific theory has ever come closer to answering these questions than string theory. Brian Greene, author of the book The Elegant Universe, briefly describes string theory in this way. In talking about the subatomic particles we just mentioned, he says, quote, "They appear to have no further internal substructure. String theory proclaims otherwise. According to string theory, if we could examine these particles with even greater precision, we would find that each is not point-like, but instead consists of a tiny one-dimensional loop. Like an infinitely thin rubber band, each particle contains a vibrating, oscillating, dancing filament that physicists have named a string. The basic idea is that these strings vibrate in different ways to form all of the different fundamental particles. To explain this concept a little bit better, let me demonstrate it with violin strings. A violin has 4 strings. The strings are all made of the same material. The only difference is that they vibrate at different frequencies, which produces different notes. When I put my finger down on one of the strings, it changes the frequency again, giving another note. Using this, one can create dozens of different types of notes with just 4 strings. These notes can then be combined to form incredibly complex and beautiful pieces of music. It's the same basic idea with string theory. These strings vibrate in different ways to produce all of these different subatomic particles. These particles then create atoms, light, even gravity, and everything that we know of in the universe. The beauty behind this theory is that it's so simple. Now we don't have multiple different theories that don't fit together well, like quantum mechanics and general relativity. Now we don't have so many different types of fundamental particles. There's only one theory and one particle that can then explain everything that we know of in the universe. In my opinion, string theory is yet another example of the brilliance and inspiration that the human mind is capable of. String theory has the potential to unlock hitherto unimagined secrets in the universe. It's my belief that as we continue in our quest for knowledge, as we continue to delve deeper and deeper into the natural world, we might just find what we're looking for. We might just find the answer to that endless question, how does it all work? We might just find that everything in the universe is tied together, maybe by string.